In this video, we'll show you how to integrate a LiDAR sensor with an autonomous mobile robot. We're using the KELO ROBILE, a modular mobile platform, equipped with Hokuyo LiDARs. Follow along as we walk you through the software setup and a basic navigation demo. The demo robot is made up of ROBILE platform with 4 active wheels or drives, 1 computer and 1 battery module, and Hokuyo light detection and ranging sensors.
I can explain about the software layer. So today we are going to use the Ros2Nav2 package. This is an open source package that will provide the ability for the navigation. And in order to get this package working, there are several packages that we will need. The first packages are the driver packages, which is the KELO Tulip, and also the URG-Node2 package from Hokuyo for the LiDAR. And then we are also going to need the ROBILE description package, which will provide us with the model of the components, the bricks, and some sensors. And then finally, we also will use this ROBILE Ros2 navigation package. This will provide us with an example for the navigation to config files and launch files. This is not mandatory, but easier to implement this because there are some examples already with different ROBILE configurations. We are going to set up the URG-Node2 package on our ROBILE. And the next step, we will need to create a new model for our new ROBILE configuration. And finally, we are going to create a new example in the ROBILE ROS navigation package to create the proper configuration for our navigation tool.
Note: we have already configured the KELO drives or wheels driver package. KELO Tulip.
So first, we start with the URG-Node2. So to cut the time, I already have the URG-Node2 package installed. Now what we only need to do is to configure the config files of the LiDAR, because currently it is still using the default IP address from the package, but this is not the IP address that we are going to use. So I will change it to this IP address because this is the one that I configured with the software. And I will also change the frame ID to scanner. This will be dependent on the model that we will use later. But for now, I will set it to be this value just to make it easy for us. And then for the second scanner, I will change again the IP address and change the node. Okay, so now we can compile and then we can launch. Okay, so it seems like it is running. And we can see that the topic is being published. Now we can try to visualize it with RFIS. So in RFIS, currently we cannot use this fixed frame because we haven't set up the model. So for now, we need to use directly the scanner link that we already set before. And then if you can see, when I set it up, you can see now the laser points from the first scanner. And if we change it to the scanner to link, we can see the laser points of the second LiDAR. So now, as you can see, This is my hand. You can see that it is detecting the scanner. Now we have the hardware running. For the KELO tulip, we already configured it, and the configuration, as Armin said, you can watch it in our YouTube, or also you can see in our GitHub. There are much more detailed examples and also explanations on how to configure it. We go to the next step, which is to create a new model.
The robot model is made up of blocks, Zacro file, for example, wheel block, LiDAR block, etc. Let's add the Hokuyo LiDAR to the Zacro file.
In general, the ROBILE is very modular, so we set up the model to be configurable. This is one example of a four-wheel configuration with two UAM05 LPA Hokuyo LiDAR, and you can see this is like the building blocks that we use. For example, this is the active wheel brick block. So we have four of them, and then we can simply add the CPU brick also and the master battery brick. And you only need to set up the origin, the coordinates of the block and also the orientation. Then you can already have the model being loaded correctly. And for the sensor, for example, we added already the Hokuyo, two Hokuyo sensors, this Hokuyo UAM05 LPA. But for this demo, we are not going to use two of them. We are only going to use one of this, and we are going to use a different Hokuyo sensor, which is this Hokuyo UST10LX. So the easiest way for us to create a new one is to simply copy this file, and then we can change this block. So I will show the example. So we copy this, and let's say we name it UAM UST config Zacro. Now we need to edit the file. So first we need to include the new sensor to the Zacro file, and luckily we already have it also in our ROBILE description package. So what we need to do is to check the directory, and then we have this file. We can use this, and it is in the same directory as the other sensor. So we can just copy this, and then we replace it to include our second sensor. Okay, so now we already included the information about the block, and now we need to replace this block down there. And then in order to change it, we can simply see the details about the file, and it tells us that this is the name of the block. We can copy, and then we can replace this. Yeah. In general, if you are using different scanner, you might need to change also the origin of the sensor. But in this case, because we are using a special holder, it is using exactly the same position, so you don't need to change it for now. Yeah, so now we have the model finished. The only thing which is missing is just to create a new example for this ROBILE Ros navigation. So here in the GitHub also you can find later the more detailed explanation. Yeah, so this is the example. And for example, this robot.launch.py, this is going to be our main launch file. This is going to call all the other launch files that we will need. So for example, this bringup.launch, this is going to call all the drivers that we will need, all the hardware interfaces that we will need. We will put it here. And the second part, which is also important, is this navigation launch part, which is going to call all the navigation 2 packages. Maybe I can show you shortly. Like in this case, in this navigation.launch, we can see that it is calling the behavior tree, the planner, the controller, and also the behavior servers. Everything is already configured. You can, if you want to make some changes, you can just simply change it in the config folder. You can change for each server the configuration that you want. But for our case, because this robot is very similar to our platform, then we don't need to do much change here. So the only change that we will need to do is in the hardware side. And we can see it in this bringup package launch file. It will start the KELO tulip. It will start the joypad also, and it will also start the LiDAR launch. And this LiDAR launch, if we see closely, it will include the Hokuyo driver launch file, and also we will add one merger node, because in some packages like the localization package, it only receives one scan. So we need to combine the 2 scans into 1 scan to make it work properly. So for the demo, what we are going to do is we are going to copy this file, the 4-wheel demo, and then let's say we name it 4-wheel AMR, let's say. And then the only thing that we need to do is to change the platform name to suit our folder name, because this is going to be used to set up all the directories in here. So we need to fix this. We need to get the correct one, and then also the model name. So this should be the name of the file that we just created today. So this is correct already. So all the directories are set up correctly. And in general, also we might need to change. Oh, sorry. We might need to change also this LiDAR.launch if we use different type of sensor. But since we are using the Hokuyo sensors now, it is not needed, because Hokuyo driver will handle all the types of these Hokuyo sensors, and we don't need to take care so much. So we just need to specify that we have 2 sensors, which is the same as in the example, this 4-wheel double UAM. We are going to use exactly the same launch file, and this should already work. The last thing that we need to do is simply, because we created new folder in the example file, we need to configure the CMake list to include the folder that we just created. So everything will be compiled and installed. So this is the okay. So now everything should be configured. Then we can compile, and then we can simply maybe I start first the RFS, and then we can launch okay. So everything seems to be running. We have everything, and then we just need to give the correct pose, let's say. Oops, wait. Maybe it is somewhere here, for example. Yeah, and then we just, yeah, when it is already localized, we can just give a pose, a goal pose, and then it will drive, basically. So this is finished. But for the demo later, we already create a video which Armin will show.
Then we did the same test with the navigation and the corridor just outside the office here. And here you can see the video of that in parallel for the simulation and the real robot. So Leo just defined a destination here, and robot is autonomously navigating, did the path planning and navigating toward the destination.
Thank you for watching. You can watch the AMR 101 webinar on KELO Robotics YouTube channel.